Claude 5. It's out. Huge news, big news. There is a lot to talk about it. In today's video, I want to share with you some of my ideas about this model, but also the narratives behind all those releases. Let's compare it with GPT 5.6, but also with some other alternative as a cloud model and local model. So let's start. First of all, this is the website. Those are the benchmark. We can see that is much better in some cases of Fable 5. In some specific parts are less capable, but overall it's incredible. And then we see this agentic coding, where actually GPT 5.6 Soul is better. And this is one of the most important elements. So maybe they should make it louder and clear that on the most important part, agentic coding, GPT 5.6 Soul is better. But they created this narrative where, look, it's not that important. Yeah, it's there, but let's not focus on here because the important part are in red. Okay, that is how they explain. So there is lack of transparency, deceiving. There's nothing wrong in being honest and say this is where we are and we are gonna get better and better and better, because on a lot of things they are better. But no, they couldn't. Now there is this other aspect, agentic coding by effort level. Pretty important metrics, but then we see the narrative here again. $1, $1.50. Okay, look at the gap. Okay, now 50 cents, now $3, 5, 7, 10, 15, 20, $30. This is the logarithmic scale, meaning that gaps here has one side, here another. So meaning that from here to here, it actually looks small, but it's actually big. From here to here, it starts to become huge. So here we have around probably $11, $12, let's say. Here we have $29. It's a gap of probably around $15, which it looks so small, but then on here it looks so big, $15. And that is the deceiving machine that they are up. Now, this is done by everybody. Even OpenAI does the exactly same thing. So they find the benchmark where they show how amazing they are. Look at this one. This is Artificial Analysis Coding Agent Index V1.1. They want to show how expensive is Fable 5, and the index score is 77.2. So if we go to Luna Max, the index score is 74.6. So the gap on index score is minimum. The gap on price is huge. It's insane. Here we see 80 and 2,454 and 77.2 and 3,700. What is happening here is OpenAI has a different way of presenting. Okay, they push their own narrative. Everybody is trying to deceive reality. Which one is the real thing? So we think, okay, maybe we go on this website and we'll find out something that is real and honest. But even here is not enough to fully understand what's going on. But at least it's not created by them, so we can have a different perspective. And we see that here is in intelligence, we have 61 for Opus 5, Fable is 60, 59 GPT 5.6. So basically it's little steps, nothing that noticeable. A step down, you can see, but it's still close, Kimi K3. You can see there are models that are not too far and they have a completely different business model that we are going to talk in a second. Intelligence is not everything, because this gap of 2 points, this gap of 1 point, it's actually in price, it's huge. So we see that Fable 5 is $2.75 per cost per task, and Opus 5 is $2.03, 154 from GPT, and Kimi K3 is 0.72. Check how cheaper this model is compared to these ones, and how not far for them it is. Now that is not everything, okay? It's not the entire narrative, because the speed is also important. Speed is token per second that get created. Here is Kimi K3 is the slowest one, 32 tokens per second. 53 for Opus, 58 from Grok, and then we see that GPT 5.6 is 77. That is, serious difference of speed, but there are much faster one. And I like this GLM 5.2, 217. So the gap of intelligence is not that huge, the speed is massive, the cost of this model is 0.32. Okay, it's just insane. The gap is insane here. Why this is important? Because most of the time we don't need the most powerful AI ever. We need the right AI for the right task. And for majority of the task, we don't need Fable, Opus 5, GPT 5.6. They're not needed. They're needed only in specific model, which I'm going to go in a second, because first I want to also show you where those Logar model actually sits, because this is another really important element to see. So at the moment here, at this level of intelligence, we see only model that can mainly run on cloud machine. There are options to run Minimax 3 and others on local AI, but it stuff requires some really good hardware. On this chart, which is the same of this top one, we can see here also some other model. I added, you can add the models by adding here, I added the Qwen 3.6 27 billion. I added this model because I use it on a daily basis on my hardware. And I use this one to do 80% of the work. This rank as an intelligence at 37, much lower than them. But what is interesting that on the RTX 5090, this model runs with quantization Q6, runs at 110 tokens per second, basically faster than any of those frontier models. So when you work with it, you feel working with a premium software because it's fast. Why speed is important? Those frontier models, what they do an insane, incredible amount of thinking. That means it's a lot of token. A lot of token at that kind of speed requires a lot of time. Time become something that is start to become really noticeable and really important, because it's there is a difference between something that you get done in a few seconds, a few minutes, or a few hours. The moment that the reply is not fast enough, what we do, we optimize and start to work on parallels. So I'm gonna have a series of projects to which I'm working in parallel, and means I have to use my mind to switch between all of them. This is a lot of work for us to do, especially when you have a lot of them, and then a few of them start to give you problems, and then you go kind of paralyzed because it's the complexity start to become huge. So the key here is to go back to simplicity, because we are like incapable, basically, at least I am. I'm not capable of dealing with that kind of a complexity. What is happening that at the end of the day, I work on 6 different projects. I get my mind confused. There is so much to do, and from feeling really productive at the beginning, I feel like I waste a day, because it's now I need to go through this back catalog of problems, and on top of other things that I have in mind. Speed is correctly so one of the most important elements. Is intelligence, speed, and cost per task are important, and I appreciate that this website is actually bring them on front so we can have an honest overview of those different models. Now going back to this one. First I want to add Qwen 3.6 35B with reasoning. I add this one because this is another really good model that a lot of people can manage to run it. So, and it sits here, okay, 32. It's less intelligent than the 27 billion, but it's still a really nice position. What a lot of people are using, sometimes are using Gemma 4, 31 billion, or the 26 billion that is even lower than this one, because they are Google, you trust them, because they're multimodal, so they can do some things that are amazing. But from my experience, because I started with them, the Qwen models are noticeably better. So let's look at how we should use those models, because we don't always need a frontier model. and thinking in a binary way that, oh, we go 100% cloud, or we go 100% on the local AI, or 100% of a specific model, is another way of approaching the problem. First of all, it's important to understand is what kind of problem you need to solve, what kind of workflow you're looking for. Let's say, for example, you're working on biology research. In this scenario, Kimi K3 is the best model because it doesn't have guardrails to stop you do that kind of research. So for some kind of scientific research, especially on biology and cybersecurity, Kimi K3 is the best. Just because those frontier models from OpenAI and Anthropic have guardrails, and those guardrails stops you to do proper research, proper work on those topics. Let's say that, for example, you just want to write. So you're a writer, you use this AI to analyze, search, co-write, whatever it is. Now, you need to find what kind of a model resonates with you. So it doesn't mean because a model is more intelligent, is better. You need to find the one that has a really nice voice. For me, for example, I don't use it often because I rather use my local AI. But one cloud model that I really like is a GLM 5.2. Nice, it's fast, it's intelligent, it writes really well. And because it's not one of those most used model, also you have some elements of originality. It doesn't write like Opus, it doesn't write like GPT 5.5. Because of this, there are things to consider according to what you want to do. Let's say that you are doing coding. I want to share this thing with you. Now we see a little bit of a different story, because look at those models. They are really, really close by. The gaps are much smaller. Why this is happening? Because the moment that you go into coding, in reality, those models have been trained with the best code, selected coding. Okay, the training material was really high, really good, really efficient. That means they are really good at doing coding. That means the next most probable token, it's a good token. And there is less need of thinking and less need of having a really powerful model. Look at Sonnet, for example. It's not that far from those other models. I want to open now Luna Max. It's here. So Luna Max basically is like a Sonnet 5. Exactly the same. 0.1 is not a point. Okay. Remember this, the cost of this Luna? It was here. Okay, that is something to consider. It's here. It's insane. So at the end, some models that even though are much smaller are still efficient. How does artificial intelligence actually work? Because we need to look into the kind of a misunderstanding. We call it artificial intelligence, but in reality it's not intelligence. What we have is a sort of really good actors. They just act in a specific way. Their acting is so good, so precise, the actual output is usable in real world. Not all the time, but a lot of time their output is usable, but it's acting. So cannot be trusted. We are not talking with an AI that is intelligent, that doesn't understand anything, doesn't have any intelligence there. It's a really good actor. Because those AI works in this way, we can say what the acting level that I require, okay, for this task. Do I need extremely high level or not? Because the cost and the speed changes. So if you want to optimize, in reality, it's about finding the right model for the right task. And if speed is what you require, you search a specific model. And again, it could be GLM 5.2, extremely intelligent, an insane amount of speed, extremely cheap. If is privacy what you're looking for, then you need to go for a local model. So this Qwen 3.6, 27 billion, it might be the option. It might be even a smaller one, because sometimes, again, it's not about the intelligence itself. Does this model do the job? And before using this 27 billion, I used to use the Qwen 35 billion A3B. It's just a little bit behind. on some tasks. This is what we're looking now is agentic work. Look, so the gap is noticeable. Let's look at the coding. So the 27 billion is doing a lot better than the 35B. And here is in overall intelligence, let's say, the gap is smaller. And even though in agentic index, the gap is start to, to be more noticeable, what I experience, I used to work with this model for running Hermes. No problem. There was never a problem in reality. It's doing the job there, working, doing what I ask. Whatever I was asking as a personal assistant would be good enough. As a coding, we see that there is a gap. There is something that is noticeable. And again, I use this model for 80% of the work that I do. So what is the other 20%? The other 20% is a subscription, it's cloud model. I have 3 subscriptions. I share this for transparency, but not because I'm suggesting you to get these ones. I'm telling you what I use and why. I use OpenAI. OpenAI has this deal that is insane. With $20, you have access to those frontier models, extremely intelligent. And like I show you, you can use Luna at max to do a lot of work at a fraction of the price. I think around 70 times cheaper than Fable 5, much cheaper even than GPT 5.6 Soul. So a lot of power and a lot of saving. This saving is connected that for every dollar that you give to AI for your subscription, they spend and on top of that one, $1.6. So they are paying to keep those tokens really cheap. So for that amount of cost that you have, you get a lot out of it. Then I have a subscription with the Kimi K3. This allows me to use actual testing the vulnerability of the software that I have. So Kimi K3 has a specific use case scenario for me and probably for a lot of other people. So again, sometimes the $20 or even the API, okay, you can use it on demand and you can do some work with it. Then I have, before I bought my hardware, I got the Minimax subscription. Now, the advantage of Minimax that is fast and is good. But if you look at this chart, look the Minimax M3 compared to the Qwen 3.6 27 billion. It's not that far. That is what is insane about this Qwen model. Okay, it's extremely powerful for the size, 27 billion. This one is probably around 300-400 billions. Those are in the trillions of parameters, multi-trillions parameters. I hope this makes sense. If you see those kind of gaps, it should make you understand what you can expect. This local model can do everything, but they can do a lot. When those models cannot do it, you have others. I got this Minimax before I bought the hardware. Now that I have the hardware, I use the Minimax when my hardware is busy. Because what's happening with the hardware? When you have a local model, you can have sometimes one or more instances of the same model running in parallel. Unless you are not working, like at the moment, my agents are not doing anything because they require always my attention in a way or another. So, but as soon as I start working, then I start parallelizing those models. On my 5090, I can run one of them if the context window needs to be long. But I can run up to 4 if the context window is small. Because I work with this model, I chat with it and I interact with it and so on. I need the entire context window. That means I only have one model. So when I want to have parallel work, then I have the Minimax, the Kimi 3, I have the older model from GPT 5.6, plus I have the Open Router. But I want to say why I don't use Anthropic models. Anthropic is a company that is actively trying to stop open source models. For this reason, I can't work with them. I'm not saying that OpenAI is better. Okay, it's just slightly maybe better, slightly different. There used to be the evil in the room, and now Anthropic managed to win that kind of a prize. So I put a line and say, okay, Anthropic is unusable for philosophical reason, okay, for value reason, for alignment. They are not aligned with my principle, therefore I don't use it. So unless you have, you're forced by your business, by your whatever you need, then yes, makes sense, use that model. Understand there is none decision that you take is perfect. There's always some problem with whatever you decide. With local model, there is cost problem, whatever it is. With the bigger one, there is other kind of value problem and environment problems and everything. Okay, they are all trying to build an AI to replace humans. Okay, that is already a good reason why not to use them. The guardrails, again, the guardrails from Anthropic are not acceptable, are too strong. We have now with Opus 5 a little bit of release of these guardrails, but stronger than what we have on OpenAI, basically not present inside what we have with the local model. So what is happening with the local model? What is why I'm so obsessed? First of all, I like the sovereignty that comes with it. I like the privacy that comes with it. But I also like the stability. That is not a small element. Stability means one thing. That when I set up my system, then I can optimize, and that system stay optimized in the way that I designed. When I work with those cloud models, this is works with any cloud models. What they need to do, they are constantly tinkering with their own hardware, with their own models to optimize for cost, consumption, parallelism, so offering the same model to a lot of different people. That act of optimization means they change elements within those models, and what is happening that you have as a user a system that is not stable. On my previous video, I talk about this because I used to do things with GPT that were extremely complex the day before and then become impossible to do the day after. That was just drive me nuts. That is the instability that I'm talking about. Those frontier models all suffer in a way or another about this. And if you've been honest with yourself, if you've been using it AI enough, you know that this is happening. You feel it, that they really fluctuate on a daily basis. These experiments sometimes are done locally. Okay, so they use maybe, for example, one nation, they do one kind of experiment, on another nation, another one, on another nation, something else. Okay, and they keep doing it. Probably on a smaller relevant nation, they do more extreme experimentation than others. So they risk less on their most important clients. But nevertheless, this is happening all over. And because of this, we have constant instability. My local model, I decide when I want to change some settings. I'm aware, and I can therefore check the output and then use the output from these new settings to understand how to fine-tune the entire system. I'm in control. With the frontier model, you are not, so sometimes the intelligence passes the threshold required for your tasks, sometimes it's not. Sometimes you make your client happy because you guarantee that kind of output. Some days you're not. So because of this reason, it's extremely risky to work with those companies. My solution, it is about build a sort of level of sovereignty, level of stability that don't require someone else to control your business. Building a business on someone that can change the power of your model, change if you have access or not, change the cost of those models. It's building your business on something that is extremely fragile. I personally choose to experiment in this direction. Again, it's unfortunately it's not sufficient to do everything that I need to do. For some people it is, for some people it's far too unusable. So it's a call that you need to make yourself. How we make this call? You need to test the model before you buy it. Okay, so if you think you need the hardware to run the model that I have, okay, this Qwen 3.6, 27 billion. At the moment, for my judgment, If you are happy with a context window of 131,000 tokens, then the 5090 is the best. If you want a larger context window, you need to go for something bigger or more than one card. If you want to run like a more powerful model, a bigger model, then you need to think about another kind of hardware, and you need to think that your model might be gonna run slower. But how we make this decision is by testing the model before you buy. So what I did, I went to Open Router, I installed this Qwen 3.6 27 billion on my Hermes, and I tested for a few days. And I checked, is this model worth the cost of the hardware? Is this model gonna do a lot of work for me, or it's not good enough? If it's not good enough, then you know it. You don't need it. If it's good enough, then you can do some math and say, okay, it's worth it or not. Those are the elements that you need to have in front of you to consider. If you're using cloud, if you're using those powerful models, understand that you don't need to use them all the time, 100%. That is a waste of tokens. You can save money and time just by optimizing the model that you use for the task. Then, if you want to use a local model, before buying any hardware, test the model. Do a research, what is the best model that you can run on that hardware. At the moment, I also own the DGX Spark equivalent from ASUS, is the GX10. The GX10 can run really well this Qwen 3.6 35 billion with 3 billion active parameter. It runs at around 60-70 tokens per second, which is faster than some of those frontier models or similar, and it's clever enough to run Hermes. It's perfect for coding. It depends what kind of coding you're doing. When we do coding, first of all, we need to look at the project itself, okay, the planning, the idea, and so on. So when we have an idea, then we need to write it down, unpack it, develop, and so on, before even we start writing the code. That part requires a long context window, a model that understands the challenges and so on. So while you can brainstorm with a smaller model and start doing, question and answer, and then put everything together into a document, then the next step is to give to a frontier model, the bigger one that you can afford, to allow this model to plan the whole software. Okay, write everything, all the specs, all the details, everything that you described needs to be turned into a proper process then AI can use to write the code. So for that one, you need a massive model. You need to look into every single details and also any single weaknesses that you didn't consider. So now you have that plan. You could do even more challenging the plan, use another model to test the plan and see weaknesses, improve it, and so on. It's up to you, it depends how big and complex the thing is. But then the next step is to write it. Some large frontier model can write all of it at once. It's gonna take time, a lot of token, but they can do it. Okay, so that could be something that you can delegate to them and do like the /go command and say, now start working, implement everything, and don't stop until it's done. For that kind of task, I would again use one of those extremely powerful models. When I say extremely powerful, I'm talking about something on this range, okay? Can be even Luna Max in most scenarios. But something that is here, okay, on this side and not on this other side, okay? We'll do something with this side. Now you have the whole system written down, which again, you can't expect to be perfect. It's gonna be good enough to start working and improving. Now, everything else from that moment on can be done and improved, even your local model, the smaller model. But hard part has been written, so now it's all about little tweaks, little changes and so on. If something is broken instead, you need to go for a model that can understand why. So the kind of work requires much more understanding. What is the best model in that scenario? It can be, of course, your whatever Opus 5, your Fable 5, your GPT 5.6 Soul, or your Kimi K3. Again, Kimi K3 has this incredible advantage on top of this other model that have the guardrails on fixing vulnerability, on searching for vulnerability. To recap, the scenario is not binary. I would suggest this mixed approach. Each one of us needs to evaluate what kind of hybrid approach you want to use, in which proportion. In my case, 80 local, 20 cloud, and the cloud that I use is depending on the task I need to do. Thanks for watching until the end. Like and subscribe, and see you in the next video.